This video discusses the procedure for the measurements experiment for general chemistry at Madison College. In the first part of this experiment, you are going to be measuring the volume of a liquid in 4 different graduated cylinders. The graduated cylinders will be set up in the front of the lab room, and they're labeled A, B, C, and D. Notice how they're different shapes and sizes. The first thing that you have to do is to determine the scale of each cylinder. The procedure you want to follow to determine the scale of the cylinder is first pick 2 numbered lines on the graduated cylinder. In this example, I'm going to pick the line that's numbered 7 and the line that's numbered 8. And I'm going to find the difference between those lines. So if I find the difference between 8 minus 7, that's going to represent a volume of 1 milliliter. Next, what I'm going to do is count the number of steps or the number of increments between the numbered lines. So if I start at 7 and count the number of steps up until I reach 8, I find a total of 10 steps or 10 increments between my 2 numbered lines. To find the scale of the graduated cylinder, I'm going to take the difference between my numbered lines and divide it by the number of steps. So if I take 1 milliliter and divide it by 10 steps, I find the scale of this graduated cylinder is 0.1 milliliters per step. Sometimes when we report the scale of a graduated cylinder, we just report it as 0.1 milliliters, and what that represents is how much the volume increases as you go from one line to the next on the graduated cylinder. The reason why it's important to determine the scale of a graduated cylinder is it tells you how many digits you can record with your measurement. The general rule that you can follow for this lab is that you're going to record 1 digit beyond the scale. So for example, if the scale is 10 milliliters for the graduated cylinder, when you go to record your measurement, you want to record to the nearest 1 milliliter. So that means you're going to be reporting your measurement to the ones place, or 1 to the nearest 1 milliliter. If the scale were smaller, if the scale were 1 milliliter, then when you add 1 digit beyond the scale, you're going to record your measurement to the nearest 0.1 milliliter. And that means that you'll be measuring to the 10th place, or 1 digit after the decimal point. All of the graduated cylinders that you'll be using in the first part of this lab have a scale that's a factor of 10. So it would be 10, 1, 0.1. The general rule is that you add 1 digit beyond the scale when you record your measurement. This 1 digit that you add is sometimes called the estimated digit, and this is when you're reading between the lines on the graduated cylinder. The other thing that you need to keep in mind is how to properly read the meniscus on the graduated cylinder. The meniscus is the curved top that some liquids have when they're in a glass graduated cylinder. The first thing is that you have to be at eye level when you read the meniscus. So you might want to squat down or bend over so that you're approximately at eye level with the meniscus. The next rule is that we always read at the bottom of the meniscus, or at the bottom of the curve. You want to find the lowest point of the curved top of the liquid and read the volume at that point. Sometimes it can be hard to see the meniscus, and things that you can use to better visualize it are, we're going to have magnifying glasses in the lab, so you can use a magnifying glass which can help you see the lines and help you see the meniscus a little bit better. The other thing that really helps is if you put a piece of paper behind the graduated cylinder, and it can make it a lot easier to see the meniscus when you're not looking through the graduated cylinder. This is an example of the data table that you'll be using for your data for part 1. And I want to go over what you're going to be recording in each column. So, the first column asks you to record the scale of the cylinder, and you have 4 different graduated cylinders that you'll be making measurements of today, and those are labeled A, B, C, and D. The scale of the cylinder is what we just determined, and that's how much each step up is worth. In the case of this graduated cylinder, I found the scale was 0.1 milliliters. The next column asks for the reported decimal place, and that's what digit am I going to record my measurement to. I know that I had one digit beyond the scale, so if the scale is 0.1 milliliters, I want to record my measurement to the nearest 0.01 milliliters, or to the hundredth space. So I know I need to have two digits after the decimal point in my measurement. In the column that's labeled your volume, you're going to record your measurement for the volume of liquid in the graduated cylinder. So when I record my volume for this graduated cylinder, I came up with a volume of 7.72 milliliters. In the next column where it says group volume, this is where you want to check in with your partner and see what their volume measurement was and how closely it matches with yours. It's okay if there's a slight difference in that estimated digit. So if your partner measured 7.73 and you measured 7.72, that would be close enough. If you see a big difference between you and your partner, you're going to want to go back to the graduated cylinder and check to see whose measurement is most accurate of the actual volume. The last thing that you're going to do in the last column in this data table is you want to record your instructor's volume. So you'll have to check in with your instructor and see what volume measurement they had for that specific graduated cylinder. The purpose of this table is that it gives you lots of practice with accurately measuring volume and recording the correct number of digits with your measurements. The next part of this lab, you're going to be finding the density of two different liquids. The two liquids that you'll be using are ethanol and water. To find the density of the liquid, you need to know the mass of the liquid and also its volume. To get the mass of the liquid, you're going to be using a 50 milliliter graduated cylinder. The first thing that you have to do is find the mass of the empty graduated cylinder, like you can see in the picture on the left. You'll record that mass in your data table, and then you're going to fill the graduated cylinder with 20 to 30 milliliters of either ethanol or water, whichever liquid you're working with, and you're going to record the exact volume. So I might record that volume as 24.7 milliliters, and I would put that volume measurement in my lab notebook. Next, you're going to find the mass of the graduated cylinder and the liquid together, like I have in the picture on the right. To find the mass of the liquid alone, I'm going to do a calculation where I subtract that final mass, the combined mass, and from that I subtract the mass of the empty graduated cylinder. So in this case, I would find the difference between 105.96 minus 85.92, and I'd find the mass of my liquid is 20.04 grams. And I'm going to use that mass to calculate the density of the liquid. I'm going to do this both for deionized water and for ethanol. In part 3 of the lab, you're also determining density, but now you're going to be determining density of a solid. The two solids that you're using for this experiment are a plastic cylinder, and the plastic cylinders, they come in a bunch of different colors, and they have a letter on the outside of the cylinder. So make sure that you record either the letter or the color of that plastic cylinder in your data table. The other solid that you're going to be using is a black rubber stopper. And notice how the shape of the rubber stopper is slightly different than the cylinder. So make sure you don't get those two mixed up. For part 3, you're going to be finding the volume of these solids using a method we call water displacement. What you want to do is get a graduated cylinder and fill it about halfway with water and record the volume of the water alone. Then you're going to take your plastic cylinder and put it inside the graduated cylinder and record a final volume, which represents the volume of the water and the plastic cylinder together. To get the volume of the plastic cylinder, you're going to do a calculation. You're going to subtract that final volume minus the initial volume. That difference in volume, how much the water level increased, represents the volume of your plastic cylinder. So you'll do that for both the plastic cylinder to determine its volume, and you'll also do it for the black rubber stopper to determine its volume in part 3. When you find the mass of the plastic cylinder and the mass of the rubber stopper, you can calculate their densities. In part 4, you're going to use the same plastic cylinder again. So I'm still using this purple plastic cylinder, and I'm going to determine its density a different way. Now I'm going to determine its volume using length measurements. So I need to get a plastic ruler, and I'm going to observe the scale of the ruler just like we did with the graduated cylinders, and make sure that you use the side, the metric side, the side labeled with centimeters. You're going to make 2 measurements. You're going to measure the diameter of the cylinder and the height of the cylinder. To calculate its volume, you're going to use the equation to calculate the volume of a cylinder. You'll get that volume of your cylinder in centimeters cubed, and you'll find its density by using the same mass divided by the volume in centimeters cubed. You should notice that the density in part 4 should be really similar to your density in part 3 because you're using the same cylinder. You just use 2 different methods to measure the volume. In the post-lab for this lab, you'll have an opportunity to analyze your data and say which method do you think is better for determining the density of a solid. So I hope this video helps you prepare for lab this week.